Hi everybody, and thank you for joining us today in this Lunch and Learn, where we're going to talk about dumb solids, make them your friend in SolidWorks. This is a topic that came out of one of the user groups. We have some great user groups, if you're not aware of it, in our area. I know some of you people attending today are participating. Some of you guys may not. You guys who don't, you're more than welcome to send me an email. It should be on the screen there. Lars@catdimensions.com, and I will definitely make sure that you get on the email blast for the different user groups we have in our area. This presentation was a user who came to me and told me that he's using SolidWorks on a regular basis, pretty good with SolidWorks, but a couple of times a year he gets these dumb solids and he's not really sure what to do with them, how to handle them, and stuff like that. So that's what we're going to try to cover today. Some of the tips and tricks on working with these imported models, because it's of course something that we can't really get away from. I made a little roadmap. That's always good, right? But some of the things we're going to talk about, solids versus surfaces. That's kind of like one of the things that you might have to deal a little bit with when it comes to working with imported models. Luckily, you don't have to know how to model a speedboat or anything like that. It don't have to be the fancy surface modeling you do. We're going to talk about file formats. We're going to talk about, of course, when you bring things into SolidWorks. My favorite power tools. There are some really neat tools when it comes to working with SolidWorks. And in the end, we're going to talk about FeatureWorks, what is a thing for our premium and professional users that have that option where you can actually take an imported model and you can actually create the whole feature tree and stuff like that. Let's jump into this. First of all, solids versus surfaces. So many times when we're talking about surfaces, many people kind of like start looking for the red exit at the door and run out. Surfaces is something that is high-end, complicated, swoopy surfaces, consumer products. But really, when it comes to working with imported models, it don't have to be like that. You will see it many times with garbage in, garbage out, or like I like to say, good stuff in, good stuff out. If you bring in a model that is not in the best shape, you might see that there's some gaps and some faulty faces on that model, and that can cause SolidWorks to create surfaces instead of an imported model. And that is just simply because SolidWorks needs the model to be watertight. I'm going to show that in a second. So we run into this sometimes. You bring in a simple model and you get all these surfaces and you're kind of like, oh my goodness, what am I going to do with all that? Or you bring in this really complicated part and you get this one imported thing and you're like, what the heck am I supposed to do with that? Now, I brought the two menus up here just because, like I said, working with surfaces don't have to become overcomplicated. And if you look at them, they're kind of like using this, and this toolbar up here we're comfortable with, right? Extrude, revolve, sweep, and all that stuff. Well, look at this surfacing toolbar. It's kind of like the same thing. Extrude, surface, sweep. It's kind of like the same mentality. So you don't really have to, be too worried about working with surfaces. It's using the same mentality. Let me just jump into SolidWorks here, and let me just open up a empty part document. And let's talk a little bit about the surfacing here. So if I go in here and I open up a sketch on the top, and I'm going to use a center rectangle here. Goes up here. Let's extrude it. Go to feature toolbar, extrude it up. Maybe grab the bar here. So this here is a solid, right? We can see that it's solid inside the folder. We know the boss extrude. We're all comfortable with this here. Well, it's a solid because it's watertight. If I go into Insert Phase and take the Delete tool here and just select Delete and remove this top face, you will see that it turns into a surface body, right? Because now that face is missing. It's not watertight anymore. Now instead, it's 5 non-thick faces here. So that's the difference between making it a solid and making it a surface. Is if it sees a gap, it will turn into surfacing. Now, just for the heck of it, if I go in here and delete these, bring it back to our original sketch. If I go to the surfacing toolbar over here and hit extrude surface, select these here, then I get 4 non-thin walled. And if I go over and use something like planar surfaces and just close the open gaps up here, Now, this don't make it a solid. This just makes it a box of non-thick walls. But if I go into the knit surface and ask SolidWorks to see if it can check it for making it watertight, you will now see that this is a solid body and not a surface anymore, right? But what is interesting is you see all these commands here. That's actually what happens with this feature. When you hit this feature, this is what SolidWorks does in the background. SolidWorks says, all right, let me just take that sketch and extrude it up. Let me close the lids and see if I can make it watertight. So, you know, sometimes when we're working with imported models, that's what we need to do. We just need to work a little bit with some surfaces and stuff like that. And it's not really something to be that worried about. And many times it's just repairing a couple of small cracks and then you're good. Or even like I'm going to show you here, that inside of SolidWorks we actually have tools that can help us with this. Now, talking about file formats, if you go to SolidWorks and you go File Open, this is the list you get here. And that's like eating at the Cheesecake Factory, right? There's a lot of options in there. And what is the best format to use? Well, I'm going to give you my favorites. You know, it's best practices. It's not always, you know, there's always exceptions, but my rules for when it comes to importing models, what kind of file formats I would ask for. So I will ask for IGES, I will ask for STEP, and I will ask for Parasolid. Now SolidWorks is written in the Parasolid kernel, so that's why that's my favorite to ask for. Interesting thing is, if we just take a look at this, now IGES was developed back in 79, 1980, by Xerox, by GE, by a couple of other companies, trying to make a neutral file format that you could bring in files for. They haven't touched IGES since 1996. So it's kind of interesting. It's definitely the most used format, but it's definitely also the one that, you know, is the oldest and haven't been touched. So it's kind of interesting that, you know, 96 is a long time ago. Now, STEP is ISO, and SolidWorks right now brings in AP 203 and 214, though the 242 is out and is available. It is. It looks like it is in beta stage right now. There's not really much information about it. I know that the difference between 203 and 214 was some automotive stuff, but generally, you know, you shouldn't be too concerned about that. They're keeping on developing on this, and I'm sure that when there's something in there that is worth for us, we're gonna get it over in our list here too. And then finally, there's Parasolid. That's the kernel that SolidWorks is written on. There's two formats. There's an X_T and X_B. One is text and one is binary. I definitely prefer to use the text over the binary. The file might be a little bit bigger, but I've definitely seen proof numerous times that the text file, things will come in better with that. Now, back in the IGES and the STEP, it's kind of interesting. You can actually open those files up in Notepad. And if you look at the IGES file, it's actually based on old punch card data. If you sat down with pen and paper, you could actually probably trace out your parts, coordinates. Whereas STEP is more like XML or HTML kind of format. It's more code like that. But in the STEP file, you can actually search for things like color and stuff like that. There is actually things that STEP files can actually contain also stuff like metadata and stuff like that. But none of the CAD companies is actually extracting that out of a STEP file. So STEP files have things in it that could be used that none of the CAD vendors are using at this point. Talking about SolidWorks files, I just wanted to throw this one up here, trying to understand, you know, when we're looking at a SolidWorks file, what do we look at? Well, with a SolidWorks file, we're looking at geometry. Now, when I'm talking about geometry, I'm not talking about lines and arcs. I'm talking about faces, edges, and points. Then we have something called topology. Now, where we have these faces, edges, and points, how does everything kind of like fit together? Then there's display data. How does it actually look on our screen, right? You will also have a feature tree, we know that. How is the part built? Possibly some custom properties and stuff like that via metadata. And if it is an assembly, then there will also be some mates in there. That's what a SolidWorks file contains. This is only what the Parasolid kernel sees. It can only see the geometry, the topology, and displays data. What this means is that this is why we don't get a feature tree when we bring in something else, because the Parasolid kernel just can't read it. It's just not, that information is just not there with a file. Now, what is interesting is that if you save a SolidWorks file out as, for example, Parasolid, or you save, sorry, not for example, but if you save it out as a Parasolid, you're actually not converting. You're actually just data dropping the information out. Where if you save it out as an IGES or a step, it actually goes through some algorithms and stuff like that. Now, interesting about this is that, like another product that is written in the Parasolid kernel, like Solid Edge. So if you had a Solid Edge file and you saved it as a Parasolid, and you then opened that Parasolid up with SolidWorks, there would never have been any converting, any algorithms run. It would literally be like data out of one file and into the other. So that would be like the pure kind of form. So it's just important to know, since they're both written on the Parasolid kernel, that then they're actually not converting, they're just data dumping. SolidWorks have a fabulous tool for importing things in. Most of the times we get popped with this right when we open up and import a model, and it's called Import Diagnostic. It can do some neat stuff. And let's just jump back into SolidWorks here, and I'm going to open up a Parasolid model here. Alright, let that open up, and I get prompted here again about the Import Diagnostic. Now if you look over here, we see that this is all surfaces. This fire extinguishers are all surfaces. Again, this is where some people are like, oh my goodness, you know, what are we going to do about this? Well, we have some neat tools, and Import Diagnostics, I always recommend people who run this. Though, if we hit yes to this, I will say that you need to be a little cautious. If your part have small gaps or it's a little weird shape, there is a possibility that Import Diagnostic will try to alter your part. Now, I still recommend you always run it, but you should just be aware of that. If we look at this part here, we can see that luckily we don't have any faulty faces, but we sure have a lot of faulty gaps. Now, I think like most other users, whenever you come in here, you see that there's one called Attempt to Heal All, and what do? You hit it, right? And you pray to the CAD gods that they might, hopefully will fix your part. Now, I hit that one, and we will see that, okay, this list got smaller, but wait a minute. I actually got another faulty face. That was not something I had before. I don't like this, right? That's not really the direction I wanted this to go in. Well, many people don't know is that we can actually hit this thing again. This is just algorithms, and you can hit it over and over and over again, and it will run on the data that it has. So hitting it again actually selects this face here. Now, of course, now I'm going to hit it again. Now it's like being in Vegas in the slot machine. But as you can see, I'm not getting anything else out of this at this point. You can, though, go in here and right-click and try to run this individually. And you will see that if I run it individually on each gap, it will actually try to fix some of them. But it will not fix this last one here. So I'm kind of like screwed here, I think. That's all I got out of that. Now I hit the green check mark. We will see, here comes FeatureWorks, we're going to talk about that later. We will see that we fixed 3 out of 4. That's pretty good, right? Without having done any changes to the model geometrically wise, we've actually fixed 3 out of 4. We can actually do better than that. There's another trick that many people don't know about, and that's called round tripping. That means that we took this part into SolidWorks, we fixed some of the things. Now, if we send it outside of SolidWorks using one of the neutral formats, such as IGES or STEP, and bring it back in again, they will actually try to repair the model too. So let's try that. So if we go out here and say Save As, I'm just going to throw this one on my desktop. So I'm going to try IGES. And you might have to try IGES or STEP, see what works best. Now I don't need this one anymore. Let's go out and open up that IGES file that is out on the desktop. It opens up. Now look at this. Now it actually don't see it as a bad surface. So it's trying to do something. We still have a little red flag here. So I'm going to run Import Diagnostic. Now we can see that it actually comes in with faulty faces. Well, hey, we know this button down here, right? Hit it. So we got 4 faulty faces. Looks like we eliminated 1 into 2 something here. Let's try to hit it again. Still nothing. Try them individually. Right click, repair face. Nope. Let's try the other one. Right click, repair face. Alright. It looks like I'm kind of like out of luck. I fixed one of them, but the other ones here are still faulty. But here's an interesting thing. When I hit the green check mark, check this out. SolidWorks was actually able to make this a solid. Now, but we still had some errors, right? We can get back into the import diagnostic tool by right-clicking here and say import diagnostic. You will see the 2 faulty faces are still in there, but it shows in here as a solid. So, in theory, this is a good solid part. There's another tool we can use under Tools, Check. And if we run that one, it will also pick up on the 2 faces in here and actually give us a little arrow and kind of like show us what the issues are. So it looks like there's a couple of issues up here near the dial. But, you know, maybe I just needed a solid model of this fire extinguisher, and I really don't care about those faces being not correct because it's still a solid, it's still a good model. If I had to do something around those dials, maybe then I would work with some of our surfacing tools. But I was able to take a part that was full of surfaces, bringing it in without changing any geometry, and actually makes this a full functional solid. So, you know, that's pretty neat that you can do that. See if we can get back to our PowerPoint here. So this is a really neat tool to use, and you should always use the import diagnostic tool. Alright, so like I talked about before, I got some favorite power tools that I like to use when it comes to working with imported models. So let's take a look at these. So first one is Move Copy Bodies. That is a really neat tool. I'm going to open up another Parasol model here. Got one here of a wine bottle. And we're going to run import diagnostic. There's nothing wrong with it. One of the things that you want to notice with this is if I turn the planes on, that this part here is actually sitting all skewed. You see that? It's like sitting in a weird angle. You know, if this was real life, we would have red stain on the carpet. It's all sitting, you know, out of whack. And that happens many times when you're working with you're bringing models in. They're not, you know, some software looks at top one way, front another way, and stuff like that. SolidWorks has a really neat tool under Insert Features that is called Move Copy. If I can hit it. Move Copy. It's sitting right here. Now be aware of it kind of like have 2 faces to it. There's one here that's using constraints like we're using in sketches and using in assemblies. And then it actually has another button over here where it can rotate it. So you can kind of like flip between the bottom button down here. And the rotate one here will let you get like this 3D gnome, and you can actually move things around if you want to. But we're going to use the other one. So let's go Insert Features, Move Copy, and I'm going to use the one with the restraints here. So I'm going to select our solid body and our imported model, and I'm going to select this outer face, and then I'm just going to select to this plane here, and you will see that it automatically makes a tangent. I like that. I'm going to hit Add to that. Select that face again. Maybe make a tangent to this place. Now it's really running on the carpet, but that's okay. We can go ahead here and maybe select this bottom ring here and this face, and maybe we just flip the direction there. And now I have actually, you know, moved this bottle right to the distance where I wanted it, right? So just like that, I can move the part around and get it placed in an orientation that I can continue working with. Now, since this is a wine bottle, there might be a couple of modifications that I want to do to it. You can see that this one should probably have been shelled out. So, I mean, I could do the shell out here. I don't know how thick we're going to make it, 50 thousandths. And there might also be, you know, like a fillet or a radius or something like that on this bottle here. And now this is maybe what I wanted. You actually, you know, in this case here, if you didn't want to, if you wanted to show in your feature tree, you could in theory round trip this part out too, again, then you will bring it back in. It will be in the right location because of this. The shell and the fill would already be in the command or in the imported. So there's a way that you could shorten your feature tree down a little bit if that's what you wanted. But the move copy tool is definitely very handy when it comes to working with placing things inside of SolidWorks. Move face. Now this is as close to magic as things as you almost get. It's kind of like interesting. Let me go in here. This is going to be an IGES file I'm going to open up. And bring it in. We're going to run the import diagnostic tool. It found a faulty face. Really? Try to attempt to heal all. Yay, SolidWorks. Feature we're going to say no to. Now, move face. There's a lot of talk about direct editing and stuff like that. And I'm ready to take the argument with people that SolidWorks already has a lot of these direct editing tools right inside of it. If I go in here and say insert face and I select move, you will see that there's 3 different stages to the move command. There's an offset, there's a translate, and there's a rotate. They really do what you would expect them to do. Check this out. If I have it on translate and I select these 2 faces, I can grab this Nomen right here and I can literally move this part out and I can make a change on the part just like that. How cool is that? Right? Let me go over here and do it on this one here. If I select the top, select the radius, I can select the bottom radius and the top radius here. Right? Again, if I grab the 3D Nomen, I can literally move this front right out there. So, when people talk about direct editing and pulling and stuff like that, SolidWorks has some of these tools. But on top of that, this is actually, one step cooler. Because of this, I actually have a dimension on this. So I can actually control this length afterwards if I want to, right? Plus, this is parametric, right? I can actually get back to where I was. So the move face is pretty neat. Another thing to know about the move face tool, right click, recent command. If you only select one face, then actually what it does is it applies material to it. So now you can see this thing got a lot thicker. So there's another thing to know. So the move face tool is pretty sweet. You bring a model in, you just need to move a couple of edges and stuff like that. The move face is definitely a tool to know that you have around. Delete. Okay, so delete is probably magic. There's something in there about the delete tool. They can do some really neat stuff. Let me show you here. I got what I would consider a fairly complex parasolid model. Let's go in here, open up parasolid. And we're going to run import diagnostic. Ooh, it found another faulty face. You can actually also right click here and zoom to selection, just if you want to see about where your issues are. And let's try to see if we can fix this. Yay for SolidWorks. No to FeatureWorks. Alright, let me just turn shade with edges on. So I showed you the delete tool before, right? That was how I took the solid and turned it into a surface. So let's call that up again. Insert, face, and delete. I'm going to use the delete and patch. Now check this out. Select this inner circle. Hole is gone. That's what the delete and patch does, is it can actually remove things right from your model. This tool is phenomenal if you're bringing in a model, you got counter bores, holes in the wrong location or something like that. You can actually use this tool to kind of like just select the faces you want to delete and SolidWorks will fix it up. Check this out. And this down here, we have something that is like a really bad import where literally we're missing a piece out of this thing clearly. Now, one thing to remember about the delete and patch tool is it's not a matter of how complicated it is what we select. It's about what's around it, because what SolidWorks does it will remove these 2 faces and it will say, all right, what can I do with the surrounding faces to make everything come together? And it can actually fix that. Okay, so really powerful stuff. And I'm not saying that I would ever be looking for models that is bad, but this tool here, it's pretty neat, man, how you can fix things just like that. Even if you're looking at design changes, many times when we get imported models, it's because that there's something that needs to be changed on the model. If we're looking at these two bosses that are sticking up there, that's a serious feature, right? Well, again, if we need to remove something with this delete and patch tool, we can literally go in and we can, select whole features like this and completely remove them. Let me just go in here so make sure I get all the different faces like that, and I can actually now go ahead here, hit the green check mark, and that part is gone, right? So this tool is really, really powerful. Now, but don't forget, because we're inside of parametric modeling, I can roll back, and there it is, right? So you got that kind of like intelligence working in there. So this tool here is phenomenal for that kind of stuff. Number 4, linear pattern. So even things that we're using in a regular day, tools works great with these imported models. Let me show you this part. Again, this is going to be an imported Parasolid. Now this is a part that I have some engineering changes to do to this part. I got this part, and this whole pattern is wrong. I actually need this whole pattern spread across the part. Now, I want to keep the first hole here as my seeded part because I want to use the linear pattern tool. I'm going to use the delete and patch tool again. So I'm going to select that. And here's another thing. When I click on here, ever see these windows, these little pop-ups coming up? They're not there to confuse the enemy. These are actually pretty helpful. So if I select this one here, it'll give me every cylindrical surface on the model. And now I can actually unselect the ones that I don't want. So I want to keep this one as seated. And now I can just pre-select these few faces here. So that's another safe tip to do that. Now I hit this one here, and it's going to delete these holes and just keep us our seated part. And now I can use a tool that we're completely comfortable with, the linear pattern. I'm pretty sure most people have used it at some point. I can go in here, and instead of selecting a feature to pattern, I'm actually going to select the faces to pattern. So I'm just going to select these 3 faces that we want to pattern, and then of course we got to do some kind of an adjustment here, and we're going to go sideways here too, something like this. And don't forget that inside the standard linear pattern we have instant to skip, so I can actually just unselect that hole there. And just like that, I took this part here, and this is a perfectly good part to work with, right? I mean, there's no we don't always need to have all the features. We can work on this. I can at any point go in here, open up a sketch, and I can go ahead here and start sketching things and start modeling things up from this part, right? I mean, this is a perfectly good solid to work with. So just so you know that a lot of the tools that we work with daily also work really nicely hand in hand with the tools that when it gets to work with the imported models. Number 5, split. Now this tool here can really be powerful, not only when you're working with imported models, but this is definitely a tool you should know about inside of SolidWorks. You can play around with and use. Let me just open up this part here. It's actually a part that we got in one of our customers' models, and I run import diagnostic. Of course, there's nothing wrong with it because it's one of our customers, right? No feature works. Now look at this part here. This is a perfect example where you bring something in and you get one imported, and you're like, what the heck am I supposed to do with this? This is clearly supposed to be an assembly model. There's a lot of stuff going on, and what I'm after here is this little stop block here. Well, this insert features split tool will let us use any faces or sketches or planes to cut our part with. So by me just going down and selecting this flat face here and hit cut part, it's actually going to cut the part into any piece that it can. Okay, so if I select here where the stop block is, that will be number 4 over here, get a check mark and hit the green check box. check out what I get here. I actually get a multi-body part. I get one that is where our stop block contained, and the other one the rest of it. So now I can use one of my favorite commands, right-click isolate, kind of like get rid of some of the stuff. And we can see here what we got out of that. We got the stop plus a few other things. So I'm just going to go ahead here and use the split tool again. So I'm going to right-click recent commands. And this time I'm going to select all the surrounding faces that are surrounding the stop block here to split that apart. So again, I'm going to hit cut part. Now in this instance here, I get a lot of different things because using those faces, I could really cut this part up in a lot of different segments. This one here is what I'm after, so I'm just going to select that, hit the green check mark, and now I can exit out of isolate. Now you will see that I have three bodies. I have the whole bottom of it, I have our split part, that's what I want, and then I have the last part of it. So if I right click here and isolate, you will see that I just cut out that stop block right out of that that imported model. But not only that, if I save this as a SolidWorks file, I can actually go up to the solid bodies and right click and say save bodies. And when I do that, I can actually go over here and select the stop block and say yes, I want to save it. And now what SolidWorks does is SolidWorks actually takes this part and it actually creates a part for us. So now this stop block is sitting in its own SolidWorks part file. So that's pretty neat that we can save that one out. We now have that stop block as a SolidWorks file. So the split command is definitely very, very helpful for that. Now the sixth one is Hole Wizard. Again, it's what we all know. My point again is, if I open up that Parasolid we just had open, many times when we get imported models, it's many times just because we need to do a couple of changes to it. We got to do a few things, and we don't need to turn this into, you know, a science of getting a full feature tree. In this part here, if all I know I need to do is adding some counterbores, so this one can actually be mounted to a table, there's no need for me to do a lot other than just opening up my Hole Wizard and place my Hole Wizard holes on here, like this here. And now I could go ahead and use something like a circular pattern. Select this edge here, whoops, select this edge. In this case here, this features, right? And just like that, I have now taken this model and put the counterboards in. This is not cheating or anything. This is fair. This is good game, and it's quick, right? So when you get many times these bodies, you can work with them for sure, just like that. All right, last on my thing here, my list is sheet metal. Some of you guys do a lot of sheet metal, some of you guys don't do it very often, some of you guys don't touch it much. I just want to kind of like show, when it comes to these imported models here, open up another Parasolid. Sheet metal works it's just as heavy to work with imported models as the rest of SolidWorks is. So I just got this little part here and a little block, imported block here. And if I go over to the sheet metal bar, I can use something like convert to sheet metal. Convert to sheet metal, select the bottom face here, that's my holding face, and I'm just going to select my bend edges around like this. And SolidWorks is so neat that it knows that it's got to rip these corners, hit the green check mark, and we actually have a sheet metal part right out of this imported model. So these tool works. Even like rips and insert bends works too. If I open up that IGES file that I had before, see here, remember this one, the move face one? If we run this one, still have an issue with the face. Something like this, you know, we can go in and use something like the rip tool to rip corners and work with corners and stuff like that. We can definitely work with these tools, and then we can insert our band, whatever works. and we now have, you know, a sheet metal part out of an import. So it's important to know that all these tools works with SolidWorks. SolidWorks, you know, has a really good core when it comes to working with these imported tools. Last thing I want to talk about is FeatureWorks. So FeatureWorks is really for our professional and premium customers. They have this option in there, and that can take an imported model like we've seen and actually make a feature tree out of it. So it's really neat stuff. I put a lot on this slide just because, you know, some of you people maybe are going to get a hold of this slide, email it to you. There's some good information on there. Let me just go in here and open up this Parasolid model. I just want to talk a little bit about the FeatureWorks thing. So if I go in here, I open up this part, run import diagnostic, no issue. I'm going to say no to FeatureWorks right now. Now, if I go in here to, FeatureWorks is an add-in because it's a part of the professional premium thing. If I uncheck it here so I turn it off, it's actually the only tool that I'm aware of, the only add-in that has its own tool, a button on the toolbar that you can turn it on from here. So even though that is off in my add-ins, I can turn it on right here. But another thing that I wasn't aware of was if I go over here in my model and I select the face, well, I came across this. Look at this. There's an edit feature. And I'm thinking, wait a minute. This is an imported model. There's no features. Well, if you click on it, because you have to see what happens, right? You will actually see FeatureWorks comes up here and says, do you want to recognize child features unselected face? Sure. And look at that. FeatureWorks actually comes right in on that feature right there. So you can actually go in here and edit feature, and in that way take that feature and turn it into a feature tree. So I'm not sure if there's something coming, where this is coming from, you know, where this is developing, because this is definitely very, very neat that you can just go in here on the fly like that and convert things over. So that's definitely worth knowing. Now, if I go over to turn regular feature recognition on, and we get the menu up here, you will see that there's two different states. There's an automatic, and there's an interactive. Well, the automatic one only really works on simple models. Models have to be simple to use the automatic one, but it's definitely, you know, feasible to use. So I'm thinking of that stop block we pulled out of that tool holder, you know, using the split command. Now you will see that if I go in here to open up that file we brought in here, you will actually see that FeatureWorks is not available. It's grayed out. Well, that's because FeatureWorks only works on imported models. Well, hang on a second. We brought in the tool holder, we used the split command, we cut everything out till we get this stop block, we saved it out separate. Now what? Now we can't use the FeatureWorks? Well, there's a trick. Remember we talked about earlier? Round tripping, right? Here I can use that tool. So I can say save as. I'm just going to throw this thing out on my desktop, and, you know, save it out as a Parasolid or something like that. And then I can get rid of this part file. I don't need that. Let's go up and hit that Parasolid on the desktop. And now I will be asked if I want to run FeatureWorks, and I'm going to say yes. And when it comes over to this automatic selection, I'm going to say go ahead. And now you will actually see that FeatureWorks will go in and create features to do this part. And this is editable features, right? Sketches and everything that we can work with. So this is really powerful way to kind of like quickly get something in, and now you could fool anybody that that you model this up, right? Now, if the part is a little bit more advanced, then the automatic one is not a good solution. You would have to use the interactive. So let's do that with that part I had up before. So I'm going to go ahead here, Parasolid, and let's go back into my documents. And I want this one here. Now, when it comes to running the interactive portion of this, down here, there is a couple of rules to keep in mind. First of all, we will see over here that we can select different types of features. You want to reverse engineer this. This is very important. You want to think about how you would model this up yourself and then kind of like go reverse. So any of you guys took a census class knows that we're supposed to put our fillets in the end of the tree. So that's what we're going to start with. We're going to go the reverse route. So I'm going to go in here and just select all our fillets on this part here. And there. Okay. And I selected those fillets. I'm going to hit recognize. Now you'll see they go away. That's a good thing because that's how things work. The thing's going to kind of like fall off as we're doing it because we're reversing engineering it, right? We're kind of like going backwards. So the next thing is maybe we got some holes in this part. So I'm going to go and select holes. And I'm going to select the interface of this holes. And check this out. That's actually recognized similar. So if I try that, think for a second, you will see that all the holes goes away. So we got onto something here. Now the next thing is maybe some cuts. I'm going to select these 3 outer cuts. Recognize. See that? Now these inside here, I could select all 3, but here it can't solve it. The solution was to do them one at a time, what I surely can do. But just be aware of that you might, have to kind of like play around with it a couple of times and just see what works and don't work. But as you can see here, as we're moving them individually, next is maybe this thing here. Looks like it might be a boss. So I'm going to go up and boss extrude. Recognize that. And finally, it's probably the first face here, right? That might be the first thing we started with. When I hit that, we will see we kind of like get a feature layout. And when we hit the green button, FeatureWorks actually goes in here and creates all the different features. It even uses hole wizard holes for all the different features. And this, of course, is full good geometry to work with. And we just took that part and completely, converted it into from one imported model to having all the different features. So FeatureWorks is definitely a powerful tool to have. It's definitely part of what I think is worth upgrading from standard to premium or professional, depending on what tools you're using. But if you're dealing with imported models, you can use FeatureWorks for maybe not the entire model, just for part of it and stuff like that. It's definitely a very handy tool to have around. So with that, I kind of like hit the end of what I had planned on for this presentation. Again, my email is there, lars@catdimensions.com. Any questions, comments, anybody want to get the list of get on the mailing list for any of the user groups in New York, email me and I'll be happy to forward those to the user group leaders. Any comments about this, anything you want to see in these lunch and learns, definitely check that out. We have a bunch of things on our YouTube channel and stuff like that too. So I really appreciate all your time. I hope you really got a lot out of that, and I hope you have a fantastic day. Thank you.